Hi and welcome to the Dutch PHP Conference 2020 edition. We're so glad that you've chosen to be here with us today. We hope you find it a valuable investment of your time. We've got a great speaker coming up for you, but real quick, I want to give a huge shout out to my buddies at iBuildings for putting on this conference all these many years. I've been involved in this conference since about 2007 when I spoke at one of the first ones and just absolutely love it. It's one of my favorite PHP conferences ever, and one of the main reasons that it's my favorite is that iBuildings puts on a great conference. So Tom, Yoni, and Angela, and all the iBuildings staff, thank you all for all the hard work that you've put into this. Now, let's get on with the show. Okay, and now up. Matthieu Napoli, yes, we're going to say it that way. Matthieu, the thing I know him for is Bref. And if you're interested in doing serverless with PHP and you've not explored Bref, then you are doing it the hard way, I guarantee you. So Matthieu is going to come talk to us today about Bref. And this is going to be a wonderful talk. I've heard him do it a couple different times. So Matthieu, with that having been said, go ahead and share your screen and take it away.
Okay, let's get started with serverless and PHP. I'm really excited to do the talk. And before starting, I just want to mention PHP. It's been 25 years since the project started. I won't do the full history, but I really like to think about the fact that before PHP came and helped us build web applications, we had to, creating a website was hard. We had to use either CGI stuff with C or maybe Perl or whatever. And then PHP came along and it made the web accessible. And I think that's something really wonderful that you can do. And I'm really excited about serverless today because I think I'm seeing the same thing. Serverless is making the web accessible again. So hi, I'm Matthieu Napoli. This is my Twitter handle if you're interested. I'm a software developer and I'm also working on open source projects. I just want to thank my sponsors. They help me spend time on open source by sponsoring my open source work, as well as what I'm doing right now, speaking at conferences. So thanks to those sponsors. And like I said, I'm a software developer. I like writing code. I don't like managing servers. I am not a sysadmin, even though I can set up a few things on a server, but I don't really like doing that. Now, I'm excited about serverless, because it helps me do more code and less serverless architecture setup or whatever. So if you don't know what serverless is or what it means, that's fine. We're going to cover that. And the way I like to explain it, very, very simply, even though it's quite not the official definition, but to me, serverless is about doing less server stuff. Spend more time coding, less time managing servers. Now, it turns out serverless is all fancy and new, but it's not that fancy and new. It's not just about code. Serverless has been there for a long time, and maybe you've been using it without knowing that. There is serverless file storage, for example. Amazon S3, using Amazon S3 instead of renting disk space is a way to go serverless, because instead of buying or renting a specific disk with a specific size and paying a fixed price, you can use Amazon S3 or any similar provider and push as many files as you want, and you don't have to manage anything. This is serverless. But you have different services like these. You have serverless databases. Firebase is a good example, and AWS DynamoDB as well. You have more and more databases like this popping up. You can have serverless message queues. Instead of setting up RabbitMQ on a server, you could pay for Amazon SQS or similar services and just start using it. Same with search engines. Instead of setting up Elasticsearch on your server, you could pay for Algolia and just use it. Don't have to worry about the infrastructure level. You have many, many more serverless services. So serverless is a very wide term, and it includes not just function as a service, which we'll see, but it includes a lot of things where basically we do less server stuff. So doing less is one of the advantages, obviously. But we can also usually scale more easily because we are relying on a provider like Amazon, like Google Cloud, like Microsoft Azure, and they are really good at scaling stuff. Sometimes, most of the time, I would say they are better than us at scaling things. So this is a good way to be able to scale more easily. And finally, we usually pay for what we use in serverless. And this is a good way to save money. So we are developers. All those services are really great, but there is one service that is interesting to us in particular, and that is function as a service. That is serverless for code. And the example I will be using here is Amazon Lambda. There are many services like this. So how does it work? Let's see how function as a service work and how we can use it to run our code without dealing with servers. The way it works is actually quite simple. We take our code and we upload it to Amazon Lambda, like we create a new, it's called the Lambda function. We upload our code in there, and that's it. And what's really interesting here is that once we've done that, the function is created, but nothing is running. Nothing is running by default, but your application, it's still there. Amazon will wait for a first HTTP request to come in. So the green arrow here is the HTTP request. It can be any event. So when there's the request that comes in, Amazon Lambda will boot instantly a container. It's like a Docker container. It uses a different technology, but those are details that we don't really care about. It boots a container, and inside that container, that Linux environment, it will run your code on demand without you doing anything. So for example, index.php will run, handle the request, return the response, and Amazon will keep the container alive just for a few minutes, just in case there's another request later, it can be handled more quickly. So let's go through that. Let's say I have a first request, I have one container that is alive without me doing anything, right? I just uploaded my code and send a request to the application. There's a second request that comes in. So the container is there, Amazon will reuse it to handle the request and run your code inside of it. Between requests, nothing is running. The container is just alive in memory, just for optimization, but you can't run anything. You just run code to react to requests or external events. Now, where it gets interesting is that if there's a third request that comes in and the first container is busy, Amazon will boot a new container on the fly, just like the first one. So it means that every execution of your code handles exactly one request at a time, just like in PHP. There is no parallelism, there is no asynchronous stuff. It's just one request per execution. So what we have here is two containers, Lambda scaled for us. That's really great. If a fourth request comes in, that's still the same behavior. Lambda will scale again. And if another request comes in again and containers are already alive and available, not busy, it will be reused to handle requests. So this is how, this is the execution model of Amazon Lambda. One execution of the code handles exactly one request, just like in PHP. Eventually, containers are garbage collected, like it's scaling up, it's scaling down. We don't configure that, but Amazon will create containers on demand and handle new requests, no problem. So that execution model is really interesting because we don't have to deal with the scaling. We can run one container, 1,000 containers. If you get a huge traffic spike and we have to handle 1,000 requests in parallel, that's fine. We don't set it up. And we only pay for what we use. So how does it work here? We don't pay for a server. We don't really manage any server here. Of course, there are servers, but we don't deal with them. So the way we pay for Amazon Lambda is via the execution time of our code. So this is the formula. It's not really helpful to get an idea of how much I will pay to actually run my code on Lambda. So let me help you get an idea, a better idea. Let's say we have this application running in production. It's a website. There's no during the day. So this is the graph of the website traffic during the day. And during the night, there is not so much traffic. We don't really need a very powerful server at that time. At 8 a.m. in the morning, people wake up, connect to the website. There's a slight traffic spike. And at 9 p.m., this is where we get most of our users. So at 9 p.m., we need a really good server. So if we were to use servers, we would buy a server that can handle that traffic spike, that maximum traffic. And at 9 p.m., this is perfect. We pay exactly for what we should be paying for. But at any other time of the day, we are paying too much because we have a machine that is too powerful. So the way I like to explain it is, if we were using serverless, we would pay something proportional to the green area here. If we were not using serverless, we would pay something proportional to the green plus the blue area, the whole box. So have a look at your production graph and statistics. Have a look at how much blue you have, because the more blue you have, the more you are paying for resources you don't use. The more blue you have, the more money you are wasting, basically. And the more blue you have, the more you could save by moving to serverless. Now, of course, it depends on the application. And it depends on how much traffic you get and how viable it is. But most of the time, you could save money by using serverless. And there are some use cases where you could actually save a lot. For example, batch processes, workers, cron stuff that are really important and we put on their own servers. So this is something that you can look out for. Now, as I said, serverless in general and serverless with function as a service can be useful to manage less things. We don't manage how things run. We don't scale things. And we can scale more easily thanks to that execution model. We also pay for what we use. I've talked about Amazon Lambda. This is one provider. This is the one I'm most familiar with, but there are many providers out there like Azure Functions, Google Cloud Functions, and many more. Now, if you want to get started, Amazon Lambda is maybe not the simplest, but it's the most popular one. This is where you will find the most examples, tutorials, tooling, and where you can learn most easily about it. So I really recommend that you start with it if you want to get started. I use Amazon Lambda the most, so this is what I will be talking about today, Amazon Lambda. And let's start talking about PHP. And what's fun is that Amazon Lambda supports Python, Node, Java, .NET, all the languages basically, but not PHP. PHP is not natively supported on Amazon Lambda. So fortunately, it's been over a year, maybe 2 years that we can run actually any language that we want on Lambda. Amazon provided extension points. So it's a bit like a Docker image somehow where you can run anything, any language you want on Lambda. But to do that, you have to create your own runtime. You have to compile PHP, and it takes some time. It's not really simple to do. So this is why I created the Bref open source project. Bref is an open source project on GitHub, and it provides PHP support on Lambda. It provides PHP runtimes as well as more things. Basically, I'm trying to provide everything that you need to create serverless applications with PHP. It's not about just the runtimes. Bref comes with a set of choices made for you. If you want to get started with serverless, there are so many options out there, so many things you have to decide which provider, which tooling to deploy, how and which architecture. Bref makes those choices for you so that you can get started easily and later change those choices if you want to. It comes, of course, with a lot of documentation, tutorials, and tools. The PHP runtime for Lambda, but also framework integrations and various tools like loggers, dashboards, and stuff like this. Now, with Bref, you can run PHP applications on Lambda. And you could write really small applications, but you can also use frameworks like Symfony, like Laravel, or any PHP application that runs on any server. To do that, Bref actually runs PHP FPM on Lambda. By running PHP FPM and PHP FPM, if you don't know what it is, it's what you use to run PHP on any server. If you use Apache or Nginx, PHP will run the same on Lambda with Bref. So it's really easy to port a Symfony or Laravel application onto Lambda. But it's not just about HTTP. Lambda was made to handle events. So you could handle HTTP requests, like those are events, but you could also handle workers and background jobs, cron tasks, many more events. This is why Bref also provides integrations with queuing libraries like Symfony Messenger. You could run background workers on Lambda with Symfony Messenger or even Laravel queues. And these are really great, and I'll show you a few examples. These are really great to have really highly scalable workers with PHP. So Bref provides all of these things, but for actually deploying, I chose not to reinvent the wheel. Instead, for deploying the applications like configuring and creating the functions, I chose to use the serverless framework. So when creating a function on Amazon, you could either do it manually in the UI, but the best thing is to automate it using what is called infrastructure as code. If you use Chef, Ansible, Puppet, Terraform, CloudFormation, all of these tools, or Docker files, even Vagrant files, all of these tools automate what you want to create on a server or on a cloud provider. And the serverless framework is just like that, except it's optimized for serverless applications. So it's much simpler to use. It's also the most popular solution used today to create serverless applications. And this is why I chose to use that in Bref. Bref is compatible with other solutions, but I will show you an example with the serverless framework. So how does it work? How can we create an application? We have to create a YAML file, serverless.yaml. We can, in the service line is how it is the name of our project. So this is the name of our application. Next, we choose the provider we want to deploy to. We'll choose AWS here. And then we can create our Lambda functions. So here I'm creating only one function, which is called web, because it will be a website or a web API. The handler line is where I want all my requests to go. Just like in Apache or Nginx or with your htaccess file, I want all my requests to go to the index.php, and then the framework will take over. Then we have a few lines to configure the runtime we want to use. We want to use Bref's runtime. So these are boilerplate lines. I don't really want to get into those details. And then I configure my function to be invoked by an HTTP API, it's called. This is just a few lines to have serverless create a URL for us. And finally, I'm including the Bref plugin. I will show you a demo in just a few slides so that you can get an idea of how it works. Now, I have created that file. This is how I configure my application to deploy. Now, instead of creating that file manually, you could also require Bref and run the Bref init command, and it will create that automatically for us. Once I have that file and I have my index.php in my project, I can run serverless deploy. Just one command, it will take my project, zip it up, upload it to Amazon Lambda, create a new function, create a new unique URL for my application, and I can use it. Now, the URL that is created here is quite ugly, but it's fine. It's just a URL for testing. We can, of course, add our custom domain here. So let me show you how it works. Hopefully it will work. Let's give it a try. So I have a new project here where I have a composer.json file where I installed Bref. Nothing really fancy here. I have my index.php file. I haven't used the framework here just for simplicity. This is a very, very simple file. Here is PHP code at the top, and then I've integrated PHP with HTML, like old style stuff. It's just to show an example. So I'm getting stuff from the request, very old school, but it's to show you that PHP runs just as usual. I'm getting a parameter and saying hello, either hello there or hello, the name that will be passed. Then I will use that message variable in the index.php file below, which is just an HTML file, really short one. So I want to deploy that file online. I've created a serverless.yaml file, which is exactly what I showed you. This is the name of my project. I'm deploying to AWS. I'm saying I don't want to use the runtime like the Node.js or Python or Java runtime. I want to provide the runtime. And this is the Bref runtime that will be provided. So this is boilerplate on how I'm providing the runtime. Next, so I will my handler for all the requests will be index.php. Every request will be sent to index.php. And let's give it a try. Let's deploy. As I mentioned, I'm just running serverless deploy. What this command will do, and it usually takes about 20 to 30 seconds, it will take my code that is in the directory, put it inside a zip file, and upload it to Amazon Lambda. This is what it's doing right now. Then it will be creating what I need. So it will be creating a Lambda function, a few permission stuff, all for us. This is Amazon. It can get quite complex, creating all the permissions, creating the temporary URL for our project. So thankfully, serverless.yaml is doing all of that for me. I don't have to set it up. And once it's finished, it should give me the URL for my application. As I mentioned, I can set up a custom domain later. I won't do it here because it can take some time. But hopefully, it should finish in a few seconds. And just to explain to you, this is how I ask serverless to create an HTTP URL. I can have functions triggered by many events, and I will show you some examples later, but this is the part where you could ask for a function to be triggered by a queue to run background workers. Now the deployment has finished, and I can see that it created my endpoint here, which is my application's URL. So let me open that. And there we go. We have our application running online. This is my index.php file. I can refresh, and it's loading quite fast. I can add a name, hello DPC2020. I can change the name again, hello Matthieu, and I can remove the name again. So as you can see, it's a perfectly fine application running correctly. I mean, nothing really specific here. So let's get back to the slides. I have a few case studies to show you. So case studies are examples of applications running in production with Bref and with Amazon Lambda and PHP. The first one is a website. I just want to show you that, yes, you can run websites on Lambda. This is externals.io. It's a website I built years ago to show the threads of the mailing list, of the internal mailing list of PHP. This is where PHP core developers discuss about RFCs and new features to add to PHP. So this is a very simple website with a MySQL database. Good response time. I'm happy with that. You can see that you can get good response time with Lambda. There's a cron task in the background that will synchronize the latest messages from the mailing list. It runs with a custom framework that I built. It's not something I'm proud of, but it works. It uses a MySQL database, and it gets about 100,000 requests per month. So not a lot of traffic, but still it's not. There's still a little bit of traffic going on. I used to run that website first on a DigitalOcean server that I was maintaining myself, but upgrading PHP, and I was afraid I was running several websites on the same server, so I was breaking everything up when I was upgrading one website or one PHP version. So I moved that to Platform SH, which is a platform as a service provider on a $50 per month plan, and then I later moved to serverless, to Amazon Lambda. And so I went from that $50 per month plan to $17 per month. Now I pay $17 per month, and $15 is actually for the database itself, because databases on Amazon start at $15 per month, but the code runs only for $2 per month. So it's Lambda is usually quite cheap to run the code itself. Now, of course, the price depends on the traffic. So let's say there's a traffic spike, like there was here in this example. It was a very popular RFC that was submitted, and I got a lot of traffic on the website, like 10 times the usual traffic over 1 or 2 days. Now, I was really happy here because I didn't have to scale anything. The website never went down. Nothing was ever slow. That was really great. But how much did I pay for that traffic spike? And I paid 4 cents extra, because Lambda is quite cheap at running code. Now I did a little calculation. Of course, I still have to pay for the $15 database, which is, if you want to run a small personal website, maybe can be expensive. But if your website starts to grow, I did a calculation. What if I got 2 million requests per month instead of 100,000? I would go from paying $17 per month to $39 per month. So this is why I really like using Lambda for this. I can scale easily and not have to worry too much about my bill scaling the same. Now, this is one case study of a website. Let's have a case study about workers. Enoptea is a French company, a French startup. What they do is they process energy bills. So they don't have a lot of web traffic, but they have a lot of background jobs running during the night or the day. And they used to run background jobs in PHP on servers, on EC2. And as they are a startup, it's doing fine. They are selling plans to clients. They are growing, running more and more jobs every month. So this is how many jobs they were running over the summer, growing. And they had to deal with that by scaling the machines and growing also their Amazon bill. So they were paying more and more each month. What they did is they started moving some services from EC2, some workers, to Amazon Lambda with Bref. And as soon as they started doing that, they started decreasing their Amazon bill. So I don't have, there are no public numbers, of course, of how much they spend in total, but they did give some numbers of one specific microservice. They moved from EC2 to Amazon Lambda, and they went from $800 per month to $90 per month. For them, it was a huge win because they were able to save money, but also because they were able to accelerate the way their worker ran. They went from processing things during 2 hours to 10 minutes because they could use the extreme parallelism of Lambda to run things much faster. And since you only pay for like the time your code is running, if you run in sequence or in parallel, it's the same price, basically. So it's a really, it's a really interesting execution model. Let's go back to the web. Here is an example of another website, but different from the previous one, because this one, even though it's a Brazilian website, it's about music and TV, it's a very popular website. And yes, you can use Lambda and Bref and PHP to run large websites. This is a website that is backed by an API with very good response time. It runs using the Falcon PHP extension. It uses the MySQL database, and it gets about 40 million requests per day. So it's one of the top 3,000 websites in the world in terms of traffic. So they get a lot of traffic. At peak time, they can go up to 2,500 concurrent Lambda executions or containers, if you want, running in parallel. So this is just to illustrate how crazy your architecture can scale. And even though they have a lot of traffic, they still manage to save some money by moving from servers using EC2 and ECS to serverless. They save 25% on their bill to run PHP, to run the code. So for them, it was a huge win as well. And finally, a last case study, which is a bit different, and I really enjoyed this project. ID Acoustic is a French company, and they are specialized in the acoustic of the workplaces, like open spaces, offices, meeting rooms. They are really, really good at what they do. And what they do is usually they come to your office or your open space and they do some measurements of how, for example, the noise bounces against the walls to see how they can make it more quiet. So what they wanted to do is to build the ID box, which is a box that they could give to partners or clients. People could go to their offices with their box, and that box has a microphone, has a really high-end speakers, has a Raspberry Pi inside, and a lot of options. And the box will actually do the measurement instead of them moving to the client's location. And they built that. I helped them build that with Python and Raspberry Pi, but we needed a way to have them collect the data from those boxes. And that's where it got interesting. I started creating a serverless application from that. For example, let's say the client runs the ID box in their office. The box has a 4G card inside, and it can upload the measure to an application. So instead of creating a large, like Laravel or Symfony application, using a framework, using a server, I just created the S3 bucket. The box uploads straight to the S3 bucket. No code or application needed here. That's really great. Now, what I want to do is when I receive a measure, I want to send an email to the client to say, good job, I received the measure. So what I did is I ran a Lambda that is triggered by files uploaded in S3. And that's something that you can do with Lambda. You can have code triggered by a new file upload. So no watching, no daemon polling, whatever. When a file is uploaded, my code will run and send an email to the client. It will say, hey, we got your measurement. Do you want to order an analysis on that? Now, in the email, the client gets a link, and that link is for a web form. They can submit it, and I built that web form with Lambda, as you can guess it. It's a really simple one-page Lambda, a very simple form. The client gets a unique URL, so the client can fill in the form, validate, yes, I want to order an analysis on that measurement. Now, whenever the form is submitted, Lambda and PHP, that's really simple. I send an email notification to the company, the ID Acoustic team, and now they need to download the file. So again, I went really simple here. You can actually use Cyberduck, which it's a FTP client, and you can configure that with Amazon S3, so they can download the file without needing any back office. Here, I created two really small functions. It took me less than 2 days to create that part, and it's been running in production and running fine. Of course, this is just the first version of the software, of the system, and it needs to be improved over time. But I really love that aspect of serverless, in that you can get started really, really quickly and really, really easily once you learn the tools, and you can prototype and get to the time to market thing. You can get to market really, really fast. And just to finish that example, I really love something. Last week, I got one of the ID Acoustic team member. He loves playing around with Python code. And I developed with PHP. I created my Lambda with PHP, but he wanted to try to process the files using Python code. And instead of setting up a server or whatever, I just created a new Lambda function and gave him full access to that. You can upload this Python code in the new Lambda function and process the files on S3. And that's a good way also to illustrate that you can give developers in the team being autonomous on what they implement without breaking anything outside of what they can do. That's really great. I really, really like that about serverless. Now, those were case studies, examples. If I were to sum up all the use cases and all the things you can do with serverless, here is a short list. You can't do everything with serverless. That's fine. You don't have to use it for everything. And I don't. I still use servers sometimes. That's fine. But here are use cases where you could think about maybe it's worth giving it a try. So small websites and APIs. These are great. And serverless is great for that because we can get really cheap hosting, effortless hosting in the sense that we deploy things and then it just runs. It's a good way to forget about setting up servers and upgrading and maintaining. It just works. So that's a good use case. It's also good for large websites and APIs. Of course, it demands more effort to make it more mature, stable, and redundant and everything, and have a good deployment process, of course. But it's still useful because you can have really scalable websites and APIs using Lambda. You have a lower total cost of ownership as well. So not the total cost when you include the development time, the time for developers, the time for DevOps engineers, all of that, when you include all of it, it could be cheaper to actually use serverless than maintaining servers and a team in rotation to watch the servers and everything. If you create back offices, and that's what I'm doing right now for a client, it's really awesome because back offices, usually you have maybe a larger application. I use Symfony, sometimes Laravel. These work fine on Lambda, and you can create a complex application, get really good performances because usually you want a good server with a large amount of RAM, a good processor, and you can do that on Lambda, but only pay for what you actually use, which is in a back office, much, much less than on a public website. You don't have many people on the back office. So it can be a really cheap way to run back offices. If you have many websites, if you're an agency, if you are a SaaS with multi-tenancy options where you deploy a lot of websites, serverless is also really, really great because you can share costs, for example, share some databases or some instances, and automate everything so that deploying a new instance of a new website, a new instance of your application really like effortless. So it's pretty interesting in those use cases. I think this is one of the most interesting use cases to me. If you have queue workers, those are perfect on serverless because they can scale without setting up anything, and you only pay for what you use. So you can have insane scale, insane parallelization for one worker during the night, and then during the day it's not running, there is nothing to do, and you don't pay for it. If you have a large company with large teams and you are doing microservices, serverless can also be really interesting there. And I've seen that multiple times. Instead of having microservices calling each other via HTTP APIs and coupling between them, you can instead use asynchronous messaging. For example, with Amazon SNS, Amazon Event Bridge, you can create really scalable and decoupled architectures. And it works really well here as well. It's a bit of an investment, but it's definitely paying off in the long run. And finally, the last use case I see are for micro functions, like I did with the ID box thing. You have just a webhook you want to deploy. Don't set up a server just for a webhook. Set up a function. That's it. It's working, and it will be working for like 10 years. If you just want to have a URL that will resize images, or a function that just generates PDF files, those micro use cases are really great. And they are a great way to get started with serverless because those are perfect. Now, to conclude, well, what should we conclude? Is serverless mature? So this is a question I was asking myself, and I had that in the slides 2 years ago. And at the time I was saying, yeah, some things are mature, but it's not completely ready. Today it is, definitely. Sure, you have to learn some things, you have to use some tools and adapt to some things that can be changing, but serverless is definitely mature. Companies are using it in production very successfully, so this is definitely worth looking into. Will serverless take over everything, and is it the future? This is hard to say. I definitely think that serverless will play a good part in our future as developers. Of course, not everything is meant for serverless. That's not like the point, but it changes a lot of the things that we can do as developers. I think it will have really huge impact on our job. Now with PHP, is PHP's future serverless? I think PHP is really interesting in the serverless space because its execution model, where we have one request, one process, it really fits how Amazon Lambda runs. And PHP is one of the unique language that is really easy to move an existing application to Lambda. So we are in a very special place where it could be really simple for us. So I'm really excited. That's what I'm really excited about PHP and serverless itself. And it could be that PHP has a great future with serverless, but of course, not only. Now, what I encourage you to do is to give it a try. Learn about it and share what you've learned. Don't start going to work tomorrow and move your big legacy application onto Amazon Lambda. This could be a lot of work. But if you have really small use cases, give it a try, and you can see how learning some stuff progressively, you can do very interesting stuff over time as you mature. If you want to get started, this is the URL for Bref, the open source project, bref.sh. There's a lot of documentation to help you and guide you to get you started. You can follow me on Twitter, where I give some advices and news related to PHP. And I'm also working on a book. It's a course. It's an interactive course where you get animations like these. You can play with stuff to see how Lambda scales, how your application can run on Lambda. So I spend a lot of time working on those animations. I'm really excited about it. So if you want to sign up for the waiting list for the course, you can go to that website, Serverless Visually Explained. And thanks a lot for listening to me. I will now try to have a look at the questions. And Carl, if you know about some questions that I can answer right now, let me know. Anyway, thank you. So, questions. So those, one of the first questions was, does Lambda supports PHP? Not yet. I'm pretty sure it will support PHP eventually, but in the meantime, you have Bref. Which color theme is your your terminal, I'm not really sure, to be honest. I think I installed it, so I don't know. I don't cover performances during my talk. I did not mention the cold start thing because I wanted to spend more time on examples and use cases. But yes, cold starts are something that you need to be aware of if you want to start using Amazon Lambda, in the sense that what is a cold start? It's when the container starts for the first time. It's usually about 200 to 300 milliseconds. So there's a slight delay when a new container starts or when the application scales. In my experience, it's fine. Unless you have some real-time API and really critical performances, those cold starts are usually not a problem, not something that you can see. There are, and you've seen all the examples I've given, like large websites, they run without any problem here. Usually, and most of the time, those are acceptable, given all the advantages that you can get from the serverless approach. Now, there are also tooling and features to get rid of those, or at least mitigate those cold starts. So if you want, you can also pay for those features and yeah, forget about those cold starts. Is the URL still available during deployment? So yes, the URL I created, let me get back here, is available as long as the application lives. Unless I explicitly destroy the application, then the URL is still there. I can just add my custom domain if I want to, but the application is there. So how much do you pay for that 100,000 requests? As I mentioned, the code itself costs about $2 per month for 100,000 requests. But it really depends on the website and the API. Here I'm serving a website, so there is additional pricing for assets. For example, I'm using the CloudFront CDN. I think 100,000 requests can actually be free because it fits the free tier of Amazon. So it could be really, really cheap. How does it work with Opcache? Opcache works on Lambda, just like on any server. We set it up, we optimize it. So Opcache is not a problem. Is the RAM configurable in serverless containers? Yes. The more RAM you set up, the more powerful the CPU is. And that's a good way to, let's say you have a worker that you want to run very fast, you give it a lot of RAM and it's really, really fast to execute. You can get really good processors on Lambda. You will pay more, but depending on how much you pay per month, it might be definitely worth it. Usually in all my applications, since I pay very little on Lambda, I set up the largest containers. Hi, Cal.
Hi there. We've got to wrap it up.
Have time? Or, yeah, okay, perfect.
We got to wrap, but we can take these other questions online into the Slack channel, and you can answer those. Thank you so much. That was a wonderful talk. Like I said, every time I see this, I learn a little more. So it's just a wonderful talk, and I love the fact that you keep giving it. So thank you so much. Okay, everybody.
Thanks.
It is now time to get up, stretch. We got about 10 minutes. Let me double check everything. Yes, at 15 till the top of the hour, we will be back with Sergey talking about improving application performance with React PHP. Woohoo! So we're going from serverless to multitasking. So I don't want to say multi-threaded because I know that's the wrong term, but anyhow, so get up, stretch. You got about 10 minutes and we will be back with Sergey. Oh, hey, make sure you go out to Joined In and leave Matthieu a comment. Let him know what he did right. Let him know what he can do better. As speakers, we always appreciate this.